This is the video for Chapter 8, Section 8.18, starting with dictionaries. The dict type implements a dictionary in Python, and by dictionary mean a set, see the braces, that means it's a set, braces mean set, of key and value pairs. These can be any type of variable. So Bobby here is a string, 67 is an integer, and 5.0 is a float. You can get one of the values from the dictionary by doing the name of the dictionary, in this case it's my dict, and putting the key into the bracket. This looks a lot like calling on a list, only we're not putting a number in here, we're putting the key, and it will return the value, which in this case 67. You can create a dictionary by using the loop. There's a dictionary built-in function here that using either keyword arguments to specify the key value pairs or by specifying a list of tuple pairs. So in some of the operations here you have, this is the one we just looked at previously. This is the name of your dictionary and whatever key you're trying to get out, and you can actually store it into a different variable if you want to. You can also add an entry by putting in a key value pair, or it will just modify the existing one. If Jose already existed, it would just modify, if maybe you had an A before, and it would be changing into a B+. You could also delete the particular value, so it deletes the key, actually the whole key from the dictionary, both the key and the value pair are deleted. And then we can also look for a key in the dictionary. So this is for a key in the dictionary, or if a key in the dictionary exists. In 8.19 lab, I would recommend that what you do is have this be read in as a string and split it and then increment by 2's, putting the first character in the key and the second into the value. So the first part of your dictionary would be Joe, colon, and then this 123-5432. Just as for strings and for list, we also have methods for dictionaries. So we have the clear method, the get method, where we can look for a key, and if we don't know whether or not the key exists in the dictionary, we can put a default in, and it will return that default if it actually doesn't find that key. Like Chad here is missing from this dictionary, so it returns the default. We can also update, and you can update by putting in a new part of the dictionary. So here I'm actually putting a new part of the dictionary in, so this is an actual entire dictionary that's being combined with the one that I previously had. Now dictionaries are set, so order doesn't matter in them. So when you print them out, they may actually appear in a different order than what you thought the dictionary was in, because order doesn't matter in a set. For the pop, you need to put in a key. If you know for sure that you have the key, then you don't need to put a default, but if you don't have the key and you don't put a default in, you could get some strange results or some error messages. So a hash is a transformation of a key into a unique value. So we can look it up really quickly. So for key in dictionary, we want the loop. So this is what we want in general. So a view object provides a read-only access to dictionary keys and values. So when we iterate over a dictionary, there's actually 3 ways we can do it. We can iterate over over both the key and the value here. So that's the items. We can iterate over the keys. So it's going through the keys and printing out the values. So when we put the key in here, the soda, it'll print out the value. Or we could iterate over the values. And when I go through the values, it's going to print the values again. So it's just printing the values. You can convert the values into a list, like this program here. Notice here that they're using the dictionary function to make a dictionary here. So we have Mars is equal to, Venus is equal to, Jupiter, and Pluto. When we do this to make a dictionary, it actually doesn't need quotes around what I would call the variables here. They're not actually variables, they're the keys in the dictionary. But it doesn't need quotes around it here. So the other way to make this, of course, would have been to put braces and put these in quotes and a colon in between. So for the second line here, they want the list of distances, so we're busting off these distances from the dictionary. So now we have a list of those distances. You can sort the list. You can figure out which one's the closest and which one's the furthest away. So the next closest sorted distance, in this case, I wanted the next closest. So the closest and the next closest is what they put, and they printed it out. This is a small reminder, too, of the scientific notation that you use in the format statements. Looking at the exercise in 8.21.1, they ask us to print the name and grade percentage of a student with the highest total of points. So that means that we're going to have to go through the whole thing here, figure out who has the highest total, which is a sum, because this is a list, and then somehow or another keep the name and the sum here so that we can do a percentage. So I want to set a total at 0 and a name. I'll just put it me. I have the highest grade. For N and grades and student grades.items. So I'm going to go over both of them because I want to know the total from the grades, and I need to know the name from the keys. So the values here are actually list, and the keys are just the names of students in the class. If I run this, I see that Tricia has a 94. I divided by 5 because there were 5 here. I could have divided by the length of the list, but I didn't really need to do that since I could see there were 5. I'm just doing a little bit of coding here. For the second part of this, I want you to find the average score of each assignment. So that means I want to add the 56, 88, 95, 76, and 99 and divide. I can see that there are also 5 people here. There's 5 things in the list and 5 separate people. So for that code, I'm going to set a list of averages, and for each of the values in student grades, notice the student grades.values. Here's the method to get just the values out. I want to go through 0, 1, 2, 3, 4 in my list here and down 0, 1, 2, 3, 4 in my students here. So what I thought to do was to add this Andrew's list of grades to each one of these zeros here, then divide by 5, because doing an average I'm going to either add and divide by 5, or I could divide each one by 5 and add them, which is what this is doing. I'm dividing by 5 and then adding. I'm also truncating here. I might not want to do that, so let me take off that division there and we'll see what kind of result we get, because we truncate every time and that would change the average. So, well, it's not truncating, it's rounding. If we do integer, that truncates. If we do the integer division with double forward slashes, that's rounding, correct rounding. So what I'm actually doing is going across each one of these and adding them in here, dividing by 5 as I go. So I'll do that for all of the people in the student grades values. So for each one of these list, that's what V is. V is a list because the values are list here. I'm going to go straight across that list and add them to the averages and divide by 5. So when I run this, I get my averages for the assignments are 82.8, 81.8, 90, 86, 70. Let's see if that one kind of looks and makes sense. So looking at the 70.6, the second one from the end, 22, 75, 85, 82, 89. So that 22 brings it down pretty far, doesn't it? So that's how you would go through and actually figure out some averages from list. The third one wants us to find and apply a curve to each student's total score such that the best student has 100% of the total. Well, we found that Tricia has a 94. So I guess what we want to do here, what I'm understanding, is that we want to add enough points. So here are Tricia's scores so that she ends up within 100. So all of hers are going to be bumped up by the amount that we need to get to 100. So again, I would make a list with 100 all the way across and then do 100 minus Tricia's here to get the curve. And then I'd go through and add the curve to each one of the students that's here, very much like we were doing the averages before. And then we can print out that dictionary and see what it looks like. I decided instead of making the list with hundreds all the way across that I actually start with Tricia's list being put into an adjuster and subtracting that new list from 100. So I get an array or a list of values that in this case would be 1, 8, 5, 11, and 1. So she ends up with 100. Notice nobody ended up with something greater than 100, so she had the highest grade on all of the tests there. So for I in the range of 5, I'm going to go through the adjuster list and just change it so that it's 100 minus Trisha's score. I tried this without the list in here, and that was a mistake because what that did was rewrite adjuster as Trisha, so it was just a pointer. So if you don't put this list in here, it's just a pointer, and it updates to Trisha. So you can see this one looks good. So let me take this out to remind you that updating a list and overriding it are not the same thing. And I end up with strange results here if I don't make this into a new list. So you see this actually took the adjuster and it somehow or another doubled it. So I guess Trisha, and then I added the same list to Trisha. So here adjuster and Trisha, this list for Trisha is the same list. It's pointing to the same place. In the 8.21.1 challenge activity, they give you the code to split a string into a dictionary. So a string is coming in, here it is, has commas and colons, so the pair split is there for pair in the entries. So entries here is the string that was split, which is a list. So looking at this, we have an input, that's a string, and then we're going to use that and split it. We could have done this in one line, and then we're going to take the country pop and make it into a dictionary. So this entry's here. I'm going to pair split on the colons. So this is just one string straight across. It's split on the commas, and then it's pair split on the colons. So this split it on the commas, this split it on the colons for the dictionary. Now your solution is going to go right here because you have the dictionary made. There's almost nothing to do here. It's one line of code. The thing that might alert you, like in 8.22 lab, that you're going to be using a dictionary is that you have pairs, original and replacement. So when you have pairs like this, it's really easy to use a dictionary. Remember that you can replace a whole thing, like the quote with automobiles, you can replace with cars using the string replace method. You can also have nested dictionaries. So once you have a container in Python, then that container can hold other containers of containers of containers. So dictionaries and dictionaries is what we have here. We have a dictionary students that's empty to begin with, and we put one student in, and his value is another dictionary. So this whole part right here is a dictionary. This is just printing a header. The grade here is printing Jose grade, so it's getting the grade part out of the dictionary. So this tells the value of the grade, which is A+. Note that grade here is what's being written in the string part of the print statement. Same is true for ID. So we're looking at Jose, we're going to the student Jose, and we're getting his student ID, which spits out his student ID in this location. Big data is a huge topic in the news right now and has been for a while. Python is really good at dealing with big data. The data structures that we have is a method of organizing data in a logical and coherent fashion. Well, a database does that, and these dictionaries like this can give you kind of a hint of how a database would be structured. So you can see grades is what I have, and I have 1, 2, 3 different students, and they have different assignments. Some of the assignments are a list of assignments, and some are just one grade for an assignment. So you have all kinds of things stored in this particular dictionary. We're going to get an input name from the user, and if the user input is not equal to exit, we'll keep doing this loop. If the user input is in grades, that means that it's one of these 3 names, then we'll go through this loop here. Otherwise, we'll ask for the user input again. And we're looking for exit. I would like it when we have an input, if we want the word exit, to actually put the word exit here as part of the prompt for the input. But oftentimes the authors of this book don't do that. So in this, we're going to get the user name. So for this first one, homework For instance, if they got Ricky Bobby is here. Then we get homeworks is equal to his homeworks, midterm is equal to his midterm, and the final is equal to his final. So homeworks for Ricky Bobby is then going to be split so that you can get the index and the score out of it. That's what the enumerate does. It splits up that list, because homeworks is just a list. Homeworks is a list. And then we'll print each of those. So he has homework, and then he's going to print the index and the actual score. The midterm is just 1, and the final is just 1. So these are not lists. But they kind of show you how you can pop those out so you can print the whole list of them. The total points is summing up all the homeworks and the midterm and the finals. And it looks like here they divide by 500 because they're counting everything equally. And once we're done with that particular printout, then we can go and do it again. The ... here is so that we could do it over and over again. It's not about what's being printed here. Notice that's not printed anywhere. Be sure to study these nested dictionaries. The more you see them, the more you see how things are aligned, the better idea you'll have of putting your dictionaries together as you're working through the rest of the course. You can find this file in the resource page in Canvas. So the first thing I'm doing here is I'm making a dictionary. You see there's only one key in my dictionary, and the value for it is a list. I want to print it out so you can see what it looks like, and this is actually printing the average. Then I want to delete student 1 and the 0, so that means I'll delete 99. Then I want to do the average again. I want to remove 87, so a couple of ways to do. There's a delete and there's a remove. The delete removes from a particular location, like this is student 1. I'm going to remove the index 0 of 99. The remove removes a value from the list, and it will remove the first value from the list here. Then I want to print the average again, see what it looks like. And then I'm going to clear out the grades. Clear gets rid of the entire dictionary, everything that's in it. Well, I shouldn't say gets rid of the dictionary, because the dictionary still exists. It just doesn't have anything in it. So it's an empty dictionary. If I print the grades out, then I can see that that's empty. I want to update it with a new one. Now remember, the update can be done without using quotes. So if you're adding to a dictionary by actually putting the values in like this, in part of the dictionary, you need the quotes on strings. But in this one, we're putting an equals in between. So an update student 1 equals 8291. This dictionary creator also takes this, no quotes, it looks like a variable, with the list that goes with it. So we have a few ways to put things into a dictionary. We can update our original, and this one I call a new dictionary here. I made a new dictionary and I upgraded it with I updated my old one, the grades, with this new one. So now the grades update should have student 1, student 2, and student 3. So let me print those out so you can see what they look like. So I can see the first thing that it's doing is giving me the average. Here's my first print. There's my first average. Then I deleted the 99. My average should have gone down because that was a high score. And then I removed the 87, so my average went up a little bit. And then I cleared out my grades and printed out what the dictionary looks like. I updated the grades. I put another part of a dictionary in, then I printed the grades out again. So now I can see student 1, student 2, and student 3. Now I want to print those individually so you can see the difference between printing out the whole dictionary and printing the actual items in it. This is the key and the value. The key prints out, doesn't have quotes around it, and the entire list is printed. So this gives a nice way that you can print out those keys and values in a dictionary. The next one says grades.items. So if you just wanted to print the items in the dictionary, that would be the whole dictionary. But notice it has a different format than when I print the dictionary out. Grades.keys is just going to print the keys. It prints it as a list, just like this did. The items printed as a list. This prints it as a list. And then the dictionary values also get printed as a list of lists in this case because they were lists to begin with. So looking at the next thing, I wanted to look at pops and gets. So if I pop a student one, or I alternatively say it's not found if it's not in there. Because if I try to pop something off that's not there, it's going to give me an error. So I leave off this part, it'll give me an error. So when I pop it off, in this case it says it's not found. And I did want you to see that it will give you an error if you leave that off. Now this one I could leave off because the student one is still there. So run that. I'll run that again and I'll show you. I popped it, but I didn't print it. And then the next one I put the not found. So we'll try that again. I'm going to take this one out also. The first time I ran it, the student one wasn't there, and now I'm getting a trace back. So I get an error message. So we get kind of the beginning of taking care of some error problems that we might come up with. So the print, the student one wasn't there and it wasn't found. And I could leave this just blank. I could just print blank and run it again. Now it's fine. You see it gave me a blank line in there, which didn't give me any information. So if I really wanted to have that student one in there, I would have no information. And you can put anything in here, like the next few lines. I put student 2, not applicable, and student 1. Student 1's already gone because I popped it here. And then I tried to pop it again, but it wasn't there. So it didn't give me an error message here. So you really can print anything, even this like small emoticon looking thing. You can print that. Now the next one I have here is a dictionary called Profile. And before I made Profile, I made a list that actually had the keys for my dictionary in it so that I could go through and not have to type out a whole bunch of stuff over and over again. So I've got keys for my dictionary. The first one is me with my birthday, and the second one is my grandma with her birth date. And there's a first initial and last name. Now, I want to run through this dictionary and actually print it. So when I do for C in the profile keys, so profile is my dictionary, and I'm popping the keys out of them. So that's just Susan Lauer and Rose Stinger. For A and B in profile C items, well, profile C is profile. This is any of Susan Lauer or Rose. So that item is actually this entire dictionary for me. So then I can separate those into keys and values. So P0 is the key, which is last name. P1 is the key, which is first initial, and then the value would be S. So this prints out my entire dictionary here a little bit at a time so that I can see what's in there. I don't think I printed the name though. So we'll take a look and see if I got the name in there, because I should have printed that. So if I run that, I can see what that looks like. It's the last name, Lauer. And I guess I already have the profile name because Susan Lauer is there, only it's not Susan. When I did the formatting here, I did a left justified and a right justified, and I filled in all the empty spaces with periods, with dots. So this was a real quick review of how that formatting should look. So the next one is lists from strings. So I've got a list, and they're having you do this all over your homework, so it's really important to be able to do this. So you first can split it off, and then my dictionary, for I in the range from 0 to the length list string 2, my dictionary list string I becomes list string. So what this really says is that I'm going to split this up, and then I'm going to take one at a time and make it into a string. So this is what happens with a string. If you have colons in here and commas, then you can split on colons and commas and end up with a dictionary, but you don't often have that. So here is if you just had a plain string and you went one line after the other, one entry after the other, putting in name, birthday, name, or whatever you're getting into it, then you could put a dictionary together using that. So if I print that dictionary, I can see it looks like A1, B2, C3. I went through the range here, every other one. So I started at 0, 1, 0, 1, 2, 3, 4, 5. So that's 0, 1, 2, 3, 4, 5.